A very good afternoon. Today I am here for discussing the topic Linux operating system. You all know what is an operating system. Bells, we are revising the operating system. The operating system is a program which starts up when you turn on your computer and runs underneath all other programs. Without it, nothing would happen at all. So operating system is a first software that runs on a machine and that helps to run the other operations, other systems, other softwares on your computer. So in simple terms, an operating system is a manager. It manages all the available resources on a computer from the CPU to the memory and to the hard disk accesses. So the operating system is a program which starts up when you turn on your computer and runs underneath all other programs. Without it, nothing would happen at all. So the tasks the operating system must perform are control hardware. The operating system controls all the parts of a computer and attempts to get anything working together. So first function of the operating system is to control the hardware so that the operating system will control all the parts of a computer and attempts to get everything working together. The second is run application. Another job of an operating system does is run application software. Means this operating system helps to run all other softwares on your computer. This would include word processor, web browsers, games, etc. So the third is manages data and the files. First it controls the hardware, then it controls the software and it manages the data and the files. The OS make it easy for you to organize your computer, means to keep which file in which drive, and through this OS or operating system you are able to do a number of things to the data. For example, you can copy the data from one drive to another drive. You can move the data from one disk to another disk. You can delete any data. You can rename the files, your folders, etc. This make it much easier to find and organize what you have. Means this help to organize your data into your memory and helps to memorize which file you are keeping in which folder, etc. So the main functions of the operating system are to control the hardware, to run the applications on your computer, and the managing the data and the files. Now we are discussing the one of the operating system, that is the Unix. Let's start with the history of the Unix. The Unix operating system was born in the late 1960s. It originally began as a one-man project led by Ken Thompson of the Bell Labs and has since grown to become the most widely used operating system. In the time since Unix was the first developed, it has gone through many different generations and even mutations. Some differ substantially from the original versions like Berkeley Software Distribution BSD or the Linux. Others still contain major portions that are based on the original source code. Now the features of the Unix operating system. Unix operating system has many reliable features that help us to do the jobs very easily and very cheaper. So first of the main feature of the operating system are multi-user and multitasking. As the name specifies, it helps to do the work multiply. Means we can do two or more things at the same time, and the work can be done at the same time by many of the users. So the most versions of Unix are capable of allowing multiple users to log on to the system and have each run multiple tasks. This is the standard for most modern operating systems. Next is over 30-year-old means the very older, having the many features. Like Unix is over 30-year-old and its popularity and use is still high, because as this Unix is available cheaper than the other Windows or other operating systems, so the demand of this Unix is still high. Over these years, many variations have spanned off and many have died off. But most modern Unix systems can be traced back to the original version. It has endured the test of the time. For references, Windows at best is half as old. Windows 1.0 has released in mid-80s, but it was not stable or very complete until the 3X family, which is released in the early 90s. So what I mean to say, this Unix is very older and very popular, and the use of this operating system is still very high as compared to the Windows, which comes into the 80s. But nowadays we do not use that Windows, but the Unix, the Linux, we are still using as more preferably than the other operating systems which are available in the market. And it has a very large number of applications. There are an enormous amount of applications available for Unix operating system. They range from commercial applications such as CAD, that is computer aided design, Maya, WordPerfect. These all softwares are the web softwares, and these are the paid softwares, to many free applications. So this is the application for many of the other applications. There are enormous amount of applications available for Unix operating system. They range from commercial applications such as CAD, Maya, WordPerfect to many of the free applications. And the fourth is free applications and even free operating system. This is the very good application that it is free. So any educational institutes can use this easily without having botheration of this is costly, this we cannot afford, and having the more features. This is the cheap and the best thing which we have, and with the many of the applications. Of all the applications available under Unix, many of them are free. The compiler, the interpreters that we are used in most of the programming courses here at UMBs can be downloaded free of the charges. Compiler is a software that helps to remove the errors from the softwares from the program. Interpreter that convert the assembly language program to the machine language programs. Such softwares which are doing many of the applications are available free of the cost. Most of the development that we do in the programming courses is done under the Linux operating system. Then the less resource intensive means it requires less resources. In general, most Unix installation tend to be much less demanding on system resources. In many cases, the old family computer that can barely run Windows is more than sufficient to run the latest version of the Linux. And the last feature is internet development. This is the most important feature of the Unix, which started from the 80s and still working and still is in demand as well. Much of the backbone of the internet is run by the Unix server. Many of the more general web servers run Unix with the Apache web server and other free applications. Means Apache web server, which is available free of the cost, are the one of the application of the Unix operating system. Now the architecture of the Unix operating system. The first thing we deal with the Unix operating system is the kernel. This kernel handle memory management, input and output request, and program scheduling. Technically speaking, the kernel is the operating system. It provides the basic software connection to the hardware. The kernel is very complex and deal with the inner working of these things. and is beyond the scope of this course. The kernel is covered in detail in the operating systems. So, the next is shell and the graphical user interfaces. This shell include the basic Unix shells which provide a command line interface which allows the user to type in commands. These commands are translated by the shell into something the kernel can comprehend and then executed by the kernel. The next is built-in system utilities. These built-in system utilities are the programs that allow a user to perform tasks which involve complex actions. The utilities provide user interface functions that are basic to an operating system but which are too complex to be built into the shell. The examples of the utilities are the program that let us see the content of a directory, moves and copy file or removes files, etc. And the last is application software and utilities. These are the not part of your operating system, but as they are additional programs that are bundled with the OS distribution or available separately. These can range from additional or different versions of the basic utilities to see the full scale commercial applications. So, I am repeating, the first is kernel, which handles memory management, input and output request and program scheduling. The kernel is an operating system. So, technically we can say kernel is an operating system. It provides the basic software connection to the hardware. And the next is shell. The shell is the basic, the Unix shell provides the command line interface where we are writing the commands and then executing them. Interfaces which allows the user to type in commands. These commands are translated by the shell into something the kernel can comprehend and executed by the kernel. Means we are writing the commands on the shell and they are executed by the kernel by understanding them. The next is built-in system utilities. These are the programs that allow a user to perform the task which involve complex action, utilities, etc. These examples are the programs that let us see how the content of a directory can be moved, can be copy files and the files can be removed, etc. Then the application software and utilities. These are not a part of your operating system, but these are the additional programs that are bundled with the operating system distribution or available separately. These can range from additional or even different versions of the basic utilities to full-scale commercial applications. Now, the flavors of the Unix means how the Unix available to us. The Unix can be available in two categories. The one is open source or the proprietary. Proprietary are the distribution or the modification prohibited or restricted which is not free. So, Solaris IRIX Mac OS, these all are the proprietary flavors of the Unix. Solaris, access to Solaris Unix server is, and the IRIX is, there are couple of IRIX machine in the basement of the library as well as server access. And the open source means those source code is readily available and free to modify and freely available to us, and these includes Red Hat, Mankande, Debian, SUC, Slaceware and many more. These all are the open source. As the Linux is an open source Unix based operating system that are originally developed in 1991 by Linus Torvalds, a Finnish undergraduate student. Now, the interface. Interface means how we can interact with the Unix. There are really two means of connecting to Unix computer. You can be sitting in front of dual bootable PC that you have booted into the Linux and logged into. All of your commands are then being run locally on your computer. When you log on in this manner, you have a full GUI, graphical user interface environment. And the other is you can connect remotely to one of the Unix server, whether from home or at the labs. This is often how your projects are suggested to be developed, as they are graded on those same servers. When you log on in this manner, you have a command line or text based environment. You can also open up a command line on a local lab machine as well. Next is the graphical user interface. When you log on locally, you are presented with the graphical environment. You start a graphical login screen. You must enter your username and a password. You also have the options to choose from a couple session types. Once you enter into your username and password, you are then presented with a graphical environment. Then we are talking command line interface. What is command line interface? You also have access to some Unix servers as well. You can log on from virtually any computer that are internet access, whether it to be Windows, Mac or a Unix itself. In this case, you are communicating through a local terminal to one of the remote server. All of the commands actually execute on a remote server, and it is also possible to open up graphical applications through this window, but that require a good bit more setup and a software. Now, what is the difference between the Linux and the Windows? This is very important area to be covered, that what is the difference between the Linux and the Windows. OS does not have any graphical interface, that is operating system does not have any graphical interface, but the OS itself, the kernel is incredibly small. The GUI just another application or a set of applications that can be installed and run on a top of the existing text-based operating system. So, the file system differences. Windows typically uses FAT32 or NTFS file system, but the Linux typically uses the ext2 or x3 file system. In much larger research and the university's environment where file access is necessary across the network, something like network file system NFS or the Android file system AFS is used. Windows lists all the drives separately like A, C, D, etc. with my computer at the highest level, where the Unix start at the highest level at the root and drive can be mounted anywhere underneath it. Now, what is the desktop manager? Gnome and the KDE are the examples of the desktop manager. Both of these look a lot like a Microsoft Windows. They have the equivalent or a start menu and have an equivalent of Windows Explorer and have some sort of control panel. The role of a desktop manager is to provide you with the ability to manage all the details of your system that would otherwise require you to type in a bunch of commands in a terminal window. These details include managing your file, launching program, configuring various aspects of your system, etc. It's also worthy to say that the desktop manager is optional. Many older systems did not have any desktop manager that sat in between X server and the Windows manager. And the window manager is a program that manages the placement of the windows on your system. The window manager makes it possible to move, resize and minimize the various programs running on your computer. The KDE handles this functionality as well, whereas Gnome does not directly provide this functionality, but rather relies on an independent window manager to do this for us. Think of the window manager as the framing around the windows as well as the associated functionality that they provide. For example, most all window managers can close, minimize, maximize and resize. However, most Unix system manager adds so much more in the way of functionality. The decoration and the customization of these windows come under Unix tends to be much more flexible. And the many window manager also provide other functionalities such as shading, sticking, non-sticking, window history, desktop and the workshop manipulations. And now the window X, desktop manager and the window manager, these most Unix systems can be installed without the GUI. GUI is graphical user interface. This GUI is just another applications that run on the top of the operating system. There are many implementations of all three of these components. It is possible to mix and match implementation and the version of these. They need not to alike and need to be all by the same organization. This is quite a shift paradigm from Microsoft and the Apple. These are the programming tools and the utilities available under Linux, and the text editors are Zemax, Emacs, Pico, VI editor, and the compilers are C compiler, C++ compiler, Java compiler, Java virtual machine, GVMac, etc. And the debuggers are C, C++ debuggers, interpreter like Perl, TCL, and the miscellaneous we have the Mozilla, Netscape, Firefox. We all are using these such browsers, etc. to do the things. Now comes the Unix command. First of all, what is the command? A command is a program which interact with the kernel to provide the environment and perform the functions called for the user. A command can be built-in shell command and executable shell file known as shell script or a source compiled or a object code file. So, this compiled code can be known as source compiled or a object code file. The shell is a command line interpreter. The user interact with the kernel through the shell. The user do not directly interact with the kernel, it interact with the kernel through the shell. You can write the ASCII text or scripts to action by the shell. And the shell sits between you and the operating system, acting as a command interpreter. It reads your terminal input and translates the commands into the action taken by the system. The shell is analogous to the commands.com in the DOS. When you log into your system or you are given a default shell, when a shell startup, it reads your startup files and may set environment variables, command search paths and the command aliases and execute any command specified in these files. The original shell was the Bourne shell sh. Every Unix platform will either have a Bourne shell or a Bourne compatible shell available. The default prompt for the Bourne shell is $ or hash or the root user. Another popular shell is C shell. The default prompt for the C shell is this sign. This Unix shell is numerous other shells are available from the network. Almost all of them are based on either SH or the CSH with the extension to provide the job control to the SH which allow inline editing of commands, page through previously executed commands, provide commands, name completion and the custom prompt, etc. Some of the more well known of these may be on your favorite Unix systems, the Korn shell KSH by David Korn and the Bourne agent shell bash from the Free Software Foundation GNU project, both based on the TC shell, etc. Now the shell programming. You can write shell program by creating scripts containing a series of the shell command. The first line of the script should be start with the sign hash which indicates the kernel that script is directly executable. You immediately follow these with the name of the shell or program. Shells are allowed. Spaces are also allowed in this to execute using the full path name. So, to set up a Bourne shell script and the first line would be hash and not sign /bin/sh. The first line is a following by the command. Within the script, hash indicate a comment from that point until the end of the line and the hash not being a special case if found as the first character of the file. For example, you can see here the example. You also need to specify that script is executable by setting up the proper bits on a file with the chmod. Now this $sign chmod plus x shell script. Now comes the Linux command. Now we are going to discuss following the commands. We categorize the command in these areas. For example, file management and viewing files, file system management commands, help job and process management commands, network management command, system management command, user management command, printing and programming commands, document preparation commands, and some miscellaneous commands. First of all, the command structure. First of all, what is the structure of the command that we are going to write? The first is command, name of the command, then the options which are used with the commands, and the list of arguments. Multiple commands can be separated with the sign semicolon, which can be executed one after the other. What helps for executing or facilitating these commands? To understand the working of a command and the possible option, we use the man command. Using the GNU info system, or we use the info command. Listing a description of a program, what is command? Many tools have a long style options help that output uses information about the tool, including the options and arguments the tool takes. For example, who am I? This helps to indicate the name of the user. Now the pipes. An important early development in Unix was the invention of pipes. This is a way to pass the output of a one tool to the input of the another. For example, who VC. This by combining these two tools, giving the VC command the output of the who, you can build a new command to list the number of users currently on the system. First of all, you are executing the who command, then we executing the WC command. The who command gives you the number of the who are you, and this helps to giving the output of who. You can build a new command to list the number of the system currently on the system. This is known as the pipes. Next, the Linux file management and viewing. The file and directory management. CD is change the current directory. With no argument, CD changes the user home directory. CD is change the current directory. If you are not giving any argument with this, it means you are changing from the home directory. Next is change the chmod. It means you are changing the file permissions. For example, chmod 751 my file. It changes the file permission to read write X from owner to the RX for group or X for other. Or one of the another example is chmod go equal to plus R my file. It adds read permissions for the group and the others. This character meaning the U for user, G for group, O for others, plus for adding the permissions, minus for removing, R for read, W for write, and X for executing. Next is the chmod, that is plus S my file. This set UID bit on a file which allow the program to run with the user or a group privileges of the file. Next are the Linux file management and the viewing commands. There are three such special permissions within the Linux. They are set UID, that used only for application. These permissions indicate that the application is to run as the owner of a file and not as a user executing the application. It is indicated by the characters S in a place of the X in the owner category. If the owner of the file does not have execute permissions, the S is capitalized to reflect this fact. The next is set GID, set GID. This used primarily for the application. This permission indicate that the application is to run on a group owning the file and not